Hello, I am Dr. J. Prasad. In this lecture, I am going to explain graphical method or corner point method. So, what is graphical method or corner point method? A graphical method is used to solve a linear programming problem involving two variables only. Okay, so this is not a general method. It is applicable to solve linear programming problems involving two variables only. So this is the limitation of this method. So we cannot solve the linear programming problem involving more than two variables by this method. So now let us see the steps involving in this method. First step, graphical method is used to solve a LPP involving two variables only. First, we represent the inequalities on a graph, that is xy plane. For this, we consider the inequalities as equalities and represent on xy plane, that is on coordinate system. Then we apply the inequality regions. Then we draw the feasible solution region. For the feasible solution region, we find extreme points. Extreme point means it is the intersection of two lines. It does not lie on any line segment joining other 2 points of the feasible solution region. Okay, so that means it is intersection of two lines. So we find the extreme points of feasible solution region. At each extreme point, we calculate the objective function value. Then the largest objective function value gives maximum value to the objective function in the case of maximization problem. The smallest value gives minimum value to the objective function in the case of minimization problem. Okay, so at extreme points we calculate the objective function values. In the case of maximization problem, we consider the largest value. In the case of minimization problem, we consider the smallest value, which gives the optimal solution. Okay, so at least one of the extreme points of the feasible solution region of a LPP gives an optimal solution to the in graphical method. So here the main point is you have to draw the inequality constraints on xy plane. For that, we consider the inequalities. Since this involves only two variables, a linear equation in two variables represent a straight line. So we require 2 points to draw a straight line, that is intercept points on coordinate axis. So we find intercept points of the lines on coordinate axis. Right. Next we consider an example. So consider this problem, simple problem. A furniture manufacturing company plans to make two products, chairs and tables, from its available resources, which consists of 400 feet wood board and 450 man hours. To make a chair, it requires 5 feet wood board and 10 man hours and is a profit of 450 rupees. Each table requires 20 feet wood board and 15 man hours and is a profit of 800 rupees. How many chairs and tables are to be prepared to get maximum profit? So this is a simple problem. First we have to convert this problem to mathematical model. Then only we are able to solve the problem. So to convert this to mathematical model, first step, identify what we have to find in the problem. So these are called as decision variables. So what are the decision variables? So here, what are the decision variables? So observe the problem. How many chairs and tables? How many chairs and tables are to be prepared? Okay. So here the decision variables are number of chairs and number of tables. Okay. So first step, identify the decision variables. So what are the decision variables? Number of chairs and number of tables. So let x1 be number of chairs. Another decision variable is x2 be number of tables to be prepared. So first we have to observe, or we have to find we have to take decision variables. So what we have to find? Okay, from that we can write decision variables. So here we have two decision variables. So that is number of chairs and number of tables. Okay, right. In the next step, what is the aim of the problem? What is the objective of the problem? So what is the objective of the problem? What is the aim of the problem? To get maximum profit. To get maximum profit. So this is aim of the problem or objective of the problem. So now based on these decision variables, what is the total profit? We have to calculate. Right. Next, objective function. That is called as objective function. Right. Observe the problem. One chair. To make a chair, it requires 5 feet wood board and 10 man hours and is a profit of 450 rupees. So one chair gives 450 rupees. So we have to manufacture x1 number of chairs. So one chair give 450 rupees profit. So x1 number of chairs give 450 x1 rupees profit. Okay. Next, similarly, one table gives a profit of 800 rupees. One table gives a profit of 800 rupees. So we have to manufacture x2 number of tables. Okay, so x2 number of tables give 800 rupees x2. 800 x2 rupees profit. Okay, so therefore total profit is sum of these two profits, 450 x1 plus 800 x2. So let it be some variable z. So total profit z equal to 450 x1 plus 800 x2. So this is objective function which represent or which gives the aim of the problem or objective of the problem. Since it is profit, in general we try to get maximum profit. Okay, so the objective function is max z equal 450 x1 plus 800 x2. Okay. So in case of profit, gains, rewards, in such cases generally we try to maximize those numbers. Okay, so here the objective is profit, so the objective function is maximization function. So max z equal 450 x1 plus 800 x2. So suppose in case of losses, cost, expenditure, in that case we try to minimize those quantities. Okay, so in that case we get the objective function as minimization function. So here the objective function is maximization function. This is the second part. So first part is identify the decision variables. Second part is write the objective function of the problem. Next, third part is what are the constraints. So what are the conditions to satisfy? What are the conditions to satisfy? Okay, right. So the manufacturing company has two raw materials, that is 400 feet wood board and 450 man hours. So the manufacturing company use 400 feet wood board and 450 man hours. Okay, right. So using these 2 man hours, the products will be prepared. Okay, so first from the problem, a chair requires 5 feet wood board. One chair requires 5 feet wood board. So we have to prepare x1 number of chairs. So x1 chairs require x1 chairs require 5 x1 feet wood board. Similarly, one table requires 20 feet wood board. So x2 number of tables require 20 x2 feet wood board. Okay, so total wood board used. So sum of these two, 5x1 plus 20x2. See it? x1 chairs require 5x1 feet wood board. x2 tables require 20 x2 feet wood board. So total wood board used 5x1 plus 20x2. Okay, so this is total wood board used based on the decision variables. But the manufacturing company has how much amount of wood board? 400 feet wood board. So what is the relation between these two? So used wood board is 5x1 plus 20x2. Available wood board is 400 feet. So what is the relation between these two? So the manufacturer cannot use more than 400 feet wood board. So the manufacturer can avail maximum 400 feet wood board. So what is the relation between these two? We get less than or equal type. So total available wood board is 400. So the relation between these two is 5x1 plus 20x2 less than or equal 400. So this is the constraint corresponding to first raw material, that is wood board. So similarly for second raw material, what is second raw material? Man hours. Man hours means working hours. Okay, that is carpenter working hours. Okay, so how many man hours are available? 450 man hours. Total maximum 450 man hours. That means the manufacturing company cannot use more than 450 man hours. It can use maximum 450 man hours. Okay, but based on decision variables, how many man hours are used? See the problem. One chair require 10 man hours. So x1 number of chairs require 10x1 man hours. Next, one table require 15 man hours. X2 number of tables require 15x2 man hours. So total man hours used 10x1 plus 15x2. So x1 chairs require 10x1 man hours. X2 tables require 15x2 man hours. So total man hours used 10x1 plus 15x2. Total available man hours 450. So what is the relation between these two? So the manufacturing company can avail 450 man hours, maximum 450 man hours. Okay, so here also relation is less than or equal to. So 10x1 plus 15x2 less than or equal 450. Okay, so these two are constraints. Okay, so we have two raw materials. For each raw material we have one constraint. So total two constraints. Next, non-negativity restrictions. So non-negativity restrictions means all variables should be greater than or equal to 0. Since x1, x2 are number of units, clearly they are greater than or equal to 0. So x1, x2 greater than or equal to 0. So therefore, the LPP is objective function, that is max z equal to 450x1 plus 800x2 subject to are satisfying the constraints, that is 5x1 plus 20x2 less than or equal to 400, 10x1 plus 15x2 less than or equal to 450, and non-negativity restrictions, that is x1 x2 greater than or equal to 0. So this is the mathematical model for that practical problem. Okay. So it is simple problem. Since it involves only two decision variables, it is a simple problem. Right, now we apply graphical method to find the solution of this problem. Since this problem involves only two variables, we can apply graphical method. Okay, so right, what is the first step in the graphical method? We represent the inequalities on xy plane. We represent these two inequalities on xy plane. For this we consider the equalities. So consider the inequalities as equalities. So consider first two inequality as equality. Consider this inequality as equality. So that is 5x1 plus 20x2 equal 400. So this is linear equation in two variables. It represents straight line. So take x1 on x-axis, x2 on y-axis. Since it represents straight line, we require coordinate intercepts. That means x-axis intercept, y-axis intercept. So find those two intercepts. How do you find the intercepts? First take x1 0, substitute x1 0 in the equation, you get 20x2 equal 400, x2 equal 400 by 20, that is 20. So this is y-axis intercept. Since x component is 0, so this is y-axis intercept. Similarly find x-axis intercept. To find x-axis intercept, put x2 equals 0. Put x2 equals 0. If x2 equals 0, here x2 equals 0, 5x1 plus 0, that is 5x1 equal to 400, so x1 equal 80. Cool. This is x-axis intercept. Okay, next consider the second equality. Consider second inequality as equality, that is 10x1 plus 15x2 equal 450. Similarly, find intercepts on coordinate axis. First take if x1 0, then x2 equal, if x1 0, this is 0, 15x2 equal to 450, x2 equal 30. Next take x1 0, so this becomes 0, sorry, take x2 0, this becomes 0, 10x1 equal to 450, x1 equal 45. Okay, so these two are intercept. So let this be 1 and let this be 2. Okay, right, now we have to draw these two lines on a graph xy plane. Okay, right, so use scale and pencil to draw the graph so that you can get accuracy. Okay, so observe the limits on x1, that is on x-axis maximum scale is 80, on y-axis maximum scale is 30. Okay, so based on these values we have to take the scale. Okay, so on x-axis, since x limits are maximum up to 80, take 1 centimeter equal 10 units. 1 centimeter equal 10 units. So 10, 20, 30, 40, 50, 60, 70, 80, up to 80. So use a scale and pencil to point out the units with equidistance, that is 1 centimeter. Similarly on y-axis limit is up to maximum 30, so take 1 centimeter equal 5 units. Take 1 centimeter equal 5 units. Okay, so here there is no negative intercept for both lines, so we consider only positive coordinate, x positive and y positive only. Okay, right, first to identify the points to draw first line. First point is 0, 20, x0, y 20, that means it lies on y-axis 0, 20, 0, 20. So this point, this is the point, 0, 20, this is the point. Okay, next second point 80, 0, it lies on x-axis 80, 0, this is the point 80, 0. Okay, so join these 2 points with scale, straight line. So this is the first line, this is the first line. Okay, right, now apply the inequality. What is the inequality? First constraint inequality is less than or equal time, less than or equal time. Okay, so how do you identify the inequality? So here observe, this line divides the graph into 2 parts, this part and this part. So 2 parts, this part is towards origin, this is the origin, this is the origin, this is towards origin, this part is away from the origin. Okay, so how do you identify the region for the inequality? Substitute origin in the inequality, substitute origin in the inequality. If the inequality satisfies origin, or origin satisfies inequality, then the region lies towards origin. Okay, right, substitute here 0, 0, x1 0, x2 0, so 0, 0 less than 400, so origin satisfies the inequality, so the region lies towards origin. So for the first inequality, the region is like this side, the region is this side, this is the region for first inequality. Okay, similarly draw second inequality. What is second line? First point on y-axis 0, 30, and this is on y-axis 45, 0, this is on x-axis. Right, So already this is first line, right? Second line, so 0 comma 30, this is y-axis, this is the point. Second point on x-axis 45 comma 0, so 45, this is 45, between 40 and 50, this is 45 comma 0, this is the second point. So join these 2 points, join these 2 points with the scale. Okay, this is second line. Similarly, second line is also less than or equal type. If you substitute origin in the second inequality, if you substitute origin in the second inequality, 0 plus 0, clearly 0, less than 450, so origin satisfy the inequality, therefore the region lies towards origin for the second line also. So this is the second line. For this, towards origin means this side, this side, this side. This is the for second line. Okay, right. Now identify the common region for both. Identify the common region for both. So what is the common region? Identify from the diagram. Observe the diagram. So this is common for both. Next from here, this is. Okay, so common region for both regions is this part, this is. Since x1, x2 are greater than or equal to 0, the feasible region lies in first quadrant only. So you have to consider the common region in first quadrant only. Since x1, x2 both are greater than or equal to 0, the feasible solution region should lie in first quadrant only. So we consider in first quadrant only. Okay, right. Now this is the feasible region. This is the feasible region. Okay, right. So clearly it is bounded. It can be inscribed in a circle of finite radius. Okay, so this is bounded. Next, to identify the extreme points or corner points. Extreme point means it is intersection of 2 lines. Okay, so for this line, this is one extreme point. So this is intersection of this line and y-axis. So this is one extreme point. Next, another extreme point is this. This is intersection of line 1 and line 2. This is another extreme point. Next, this is another extreme point. This is intersection of second line 2 and x-axis. Next, this is origin. This is also intersection of x-axis and y-axis. So for this feasible region, we have 4 extreme points: A, B, C, O. That is O, A, B, C. Okay, so this is feasible region. So the feasible solution region is O, A, B, C, which is bounded. The extreme points are O, A, and B and C. The extreme points are O, A, B, C. Next, so we can easily identify the coordinates of the extreme points O. So O is origin, 0, 0. A is on y-axis. This is 0, 20. C, this is on x-axis, 45, 0. You can easily identify these 3 points. Okay, right. Now how do you identify B? Since it is rough graph, we have to solve the 2 equations. B is intersection of the 2 lines, equation 1 and equation 2. Solve the equation 1 and equation 2, you get the point B. Okay, how do you solve the 2 equations? Make the coefficients equal to one of the variables and add or subtract to eliminate that variable. Then you can find the second variable. Okay, so observing the 2 equations, first equation is 5x1 plus 20x2. Second equation is 10x1 plus 15x2. Okay, so here we have 10, here we have 5. So multiply first equation by 2. You get 10x1 plus 40x2 equal 800. Second equation as it is. Then if you subtract, then x1 eliminates, you get x2. Okay. Okay, so multiply first equation by 2, second equation as it is, subtract, so x1 gets cancelled, then 40 minus 15, 25 x2 equal 350, then x2 equal 40. Okay, right, now substitute x2 in first equation or second equation. So substitute in 1, so 5x1 plus 20 into x2, that is 20 into 14, 280 equal 400, from this x1 equal 24. Okay, so the point B is 24 comma 14, so x1 is 24, x2 is 14, this is B. Okay, so we have all 4 extreme points. Okay, next find the objective function value at extreme points. So write in table form, these are extreme points: O 0 0, A 0 20, B 24 14, C 45 0. Calculate the objective function value at these extreme points. Objective function is 450 x1 plus 800 x2. Substitute this point: 0 plus 0 0, next to 0 comma 20, that is 450 into 0 plus 800 into 20, that is 16,000. Next to substitute x1 24, 450 into 24 plus 800 into 14, that is 22,000. Next to substitute x1 45 and x2 0, 45 into 450, that is 20,250. So these are objective function values at these extreme points. Right, now since the objective function is maximization problem, we consider the largest value, the largest objective function value. So what is the largest objective function value in this? 22,000. This is the largest objective function value. Since the feasible region is bounded, we can take this largest function as maximum value to the objective function. Okay, so optimal solution occur at the extreme point B, at the extreme point B. Okay, so what is the solution? x1 equal 24, x2 equal 14. x1 means number of chairs, so number of chairs, x1 equal 24, x2 means number of tables, equal 14. Then what is objective function value? 22,000. So objective function means here the profit, so maximum profit is 22,000. Okay, so this is optimal solution to the problem. So what is the meaning of this optimal solution? That means the manufacturer should manufacture 24 chairs and 14 tables, then he get maximum profit 22,000 rupees. Okay, so that is the meaning of this solution. Okay, consider this solution. 0 0 means x1 0, x2 0, then objective function value 0, that means no product, no profit. That is the meaning of this. X2 0 comma 20 means x1 0, x2 20, that means no chairs. If the manufacturer produce only tables, that is 20 tables, then he get profit 16,000. What about C? x1 45, x2 0, that means if the manufacturer produce only 45 chairs, then he get the profit 20,250 rupees.